Hello fellow AGDXers, welcome back to another video. Today we're going to be talking about collision and proximity detection. So one of the things that some people have said to me about AGD games is they find them a little bit frustrating because collision detection isn't very precise, and it's certainly true that collision detection basically is the same for every sprite, and it does mean that if you have a sprite which doesn't fit the 16 by 16 or 24 square, then you don't really get that pixel perfect accuracy. So I've added a new routine, and I'm going to show you how to install it now. What you need to do is you go to the character set, assume you've already downloaded it, go to load binary data, and after you've unzipped it, you should load 31976 underscore proximity bin. Load it in at 31976, and that is just here. So you're using up 3 characters there of the character set. It is possible to move it from here to another place in the code if you want to. You just need to adjust the pokes, read the documentation about that. You need a little bit of knowledge, but it's quite simple. Next thing you do, open the proximity.poke, and I'll just move this over so you can see. And these 3 pokes basically will change the hit detection for AGD, redirect it to our code, and then send it back so that AGD behaves as normal. You don't need to run any assembly routines or anything like that. You just do the normal detection, but we've added a few extra lines that will assist us here to make the collision detection more manageable for the coder. Okay, so the first thing that this manages to do is it allows us to have detection of proximity. So as you can see, I've got a little demo sprite here from Andy Johns' game, and I've got 3 little enemies here which are static, and what I want them to do is react when the player gets close to them. And as you can see there, I've triggered some code. Just move the mouse out of the way. There you go. I've triggered some code there which will cause these plants to lock up when the player gets near them. So you know, you find this, I think, in Mario games, for example, where there's a bomb that will set off if you go near it, or it'll chase you, or something like that. So, okay, so the first thing you do in this case is we put in if hit 0, that's the player, and end if. We don't have any hit code because we can add hit code, but we don't need any here. All we need is to run that code, because that will then transfer the calculate rather the distance in terms of line or column from the one sprite to the other in pixels, and it measures distance. So it doesn't measure, for example, -8 and +8. It just measures the distance, which is quite handy because obviously then you can easily just measure from any position. It will tell you how close it is. And what we've done there is we basically then add line to column. So these 2 variables, line and column, are added together to get a rough idea of the distance. And then you can see the code. We check the frames and we adjust the frames accordingly. It's pretty straightforward. You can pause the video on that script and type it in if you want to try it. Okay, so that's basically how that works. It's, as I said, pretty straightforward. The line and column variables, you can use them anywhere you want still for writing text and so on. They're just used temporarily because it's easy to remember line and column. Line is horizontal, column is vertical, and so it's pretty straightforward. And you can have a play about with this, as I'm going to show you here. For example, if I put a sprite right in here, then we should get the effect that the plant will actually run away, so that's quite fun as well. Obviously you'd need to add some additional code in there if you wanted the sprite to check if it was to the left or to the right. You'd have to measure the player variable and compare it, but it's not that difficult to do if you want to try that too. Okay, so that is that section. That's the first thing, just basic proximity detection, and it could be quite a nice game mechanic, I think. But this was a kind of happy accident, really. It's just something I decided to add. The main thing I wanted to do was to be able to measure the extent of a collision, and this demo will show you the problem that we have with AGD. Here I've got a water droplet which is falling, and it's quite a small, narrow sprite. It's not 16 by 16, and I've set the border to go to red when the collision is detected. And as you can see, very clearly that our little sprite is not being hit by that drop of water. So if AGD thinks that it is, then obviously that's going to cause frustration for the player immediately, because it isn't fair. Simple as that. You can see the player is making his or her decisions based on the position of the sprite, and the visual information isn't giving you an accurate representation of the actual collision. So the two things don't match. That's unfair. Player frustrated. Player probably won't continue with your game, or at least won't have as high opinion of it as you might like them to. So let's look at how we fix it. Pretty straightforward here now with this code, because line and column will give us the extent to which the collision is, how accurate the collision is, let's say, because the closer to 0 it is, the larger the collision, the more direct the two sprites are over each other, because obviously if the distance is only 2 or 4 pixels, then that's a bigger hit than, say, 14 pixels. So here, this is standard AGD code there. The top part is just the movement, and all we have to do to make our hit detection more accurate is put a check in this case, because the sprite is very narrow. We're going to put a check on the column variable, which we know will tell us the extent of the collision. So I'm going to put it here within only 6 pixels. So rather than within 15, 16 pixels, we're going to change it now to be only within 6 pixels, which is the width of the sprite. So we'll add that in there, and as you'll see now, if we go and test it, we should see that the distance between the two sprites will only trigger a hit if the sprite is completely overlapping. So let's take a look here. As you can see, we're close and we're getting nothing, and now, and one more step maybe, there you go. So that's a lot more accurate, isn't it? It's basically what you can see is actually what is happening in terms of the collisions, which means that the feedback that you're giving the player is accurate to the code that you're writing, which is of course fundamental in any good game, any fair game, let's say. Okay, so that's basically that. It's nice and simple, nice and straightforward, and a good example, I think, of how you can, as I said, make the game a bit fairer. Okay, now let me just make a small adjustment here, because I've just realized that I need to put the border in here, the border 0. That will show it a little better. As you can see here, a little step closer, one more, and there you go, there. So that actually accurately shows the position. I could, if I wanted, adjust the horizontal. If that drop was a little bit smaller, I could also set the horizontal to give the player a better chance of kind of ducking under it as well. Something that you can play about with, experiment until you get it so that it actually feels right. As I said, I can't really emphasize enough, this kind of polish really makes a big difference to the person that's playing your game. Okay, let's look at one more example. In this case, we're going to look at a horizontal example, and again, very common in platform games. We want to have an accurate jump over a object or a sprite in this case, and we want the player to be able to jump over the object quite easily. So I'm using the same sprite, and as you can see here, I've got the setup so that the border goes red, and as you can see, I'm jumping over that sprite. I'm not being hit, but it is recording it as a hit, and obviously, again, just not really fair, is it? So let's look at how we can fix it. I'm sure you can probably predict that basically all we have to do, as you can see, I fixed it here. There you can see, just to prove I am being hit there, but I can now just let me get it right first. There, you see, it's perfectly possible. So it might be difficult, it could be difficult to jump over. You've got to get the timing right, but if you get the timing right based on the visual information you're given, then it's difficult, but it's not unfair. And those two things are, of course, very, very different when it comes to writing games. Games can always be difficult, but they should never be unfair. So yeah, and as you can see, this is how we do it. We add an offset here, add 8 to x and sub 8 to x. That's so that we're only dealing with the bottom part of the sprite. We're assuming here that this is a platform game and we're not going to be detecting below the sprite. We can assume that the two sprites are on the same level. And then we just put in here line and column check, 13 pixels wide, which would be 14 wide, and 12 here. So we're basically checking, I should say, sorry, 12 by 10. Yeah, because greater than 13, less than 13, isn't it? So, okay, so again, adjusting for the size of the sprite individually. You can, of course, adjust sprites within AGD in terms of the hit distance. I think I can probably show you that in a second. But this is sprite specific and image specific, and so you can basically create a kind of a hitbox and it will work. So as you can see, we'll just go back one more time, and yeah, much fairer. Okay, as I mentioned, you can do this in AGD in a sort of general setting if you go to the miscellaneous menu, and that will allow you to change all of the sprites. But this system, of course, will allow you to adjust the sprite individually, which is, of course, much better, because you don't really want to have all of your sprites being kind of 16 by 16 pixels necessarily. Will look kind of generic. And I think that the collision detection system in AGD, of course, it's simple and it works, but it does tend to lead to games being quite similar in terms of the sprites that are used and so on. So hopefully with this, you might find that you can now use other sprites and make your games have a little more variety, a little more interest, and obviously, as I said, also to be more accurate and fair to the player. Okay, so that's about it really for today, I think I would say. So thanks again for watching. I hope you found that useful and interesting. And I'll be, as always, on the Facebook page, so please go and check out that. And I'll see you soon. Thanks a lot. Happy coding. Bye-bye.